Hi, let me know when you can hear me. Is my voice audible? Okay. We'll start in a couple of minutes. Kaushik, I have included, I think, one or two questions from the ones you had posted. Not all of them, because the ones I felt were more informative, I have included them. So we'll have that towards the end of the class. And we'll start in a couple of minutes. Meanwhile, if you have any doubts on the previous class or any questions otherwise, you may type in right now. But we'll start very shortly. For those who are tuning in, it's good to watch the session, but just watching the sessions won't help you solve questions. Once you have watched the session, you'll need to spend at least 2-3 hours in making things perfect. So you should reach the stage where you can take the session rather than watch the session. And I'm fairly sure that if somebody revises properly the previous session and the one that we'll have today, post that, they can solve like 99% of the questions on speed, time, and distance. So you tick one more box just by spending 10-15 hours on one topic. You'll be able to tick one more box. Like if you get a question on speed, distance, time, you should be confident that this one too I can solve because I have done it properly. But that will only come if you like write down the sessions yourself, write down twice maybe, then you get comfortable with all the concepts and the related examples, etc. Just by listening in, you do get a bit better, but not a lot better. Listening to the class should just be the first part of the entire process. So I think we'll start a couple of minutes early, but it's fine. Uh, so we plan to cover circular motion today. We'll cover circular motion and clocks related concepts, and then I'll do a set of questions. The questions are covering both what we'll study today as well as what we have studied previously. So we'll do both of that. Just give me a second. Let me see if I can move it a bit. Yeah, I think this would work better. So we'll do that. So we are starting with the first question. So circular motion. There is a track. Let's assume that this track is 600 meters long. So it's a circular track, sort of a jogging track or something, which is 600 meters long. And there are two people running. One person is running at 5 meter per second, and another person is running at 3 meter per second, and they both are running in the same direction. Okay, and the question is, after what time will they meet at the starting point? So after how much time will they come back to the starting point? So let's see how we can answer this question. Let's look at first. So it's a 600 meter track and somebody is running at 5 meter per second. So the amount of time he will take to run one lap would be 600 by 5 or 120 seconds. And the other guy who is running at 3 meter per second, the amount of time he'll take is 600 by 3 or 200 seconds, right? So the first guy will take 120 seconds and the second guy will take 200 seconds. So when will they meet at the starting point? So the first guy, let's put this guy as 1 and this is 2. The first guy will come back to the starting point at 120, 240, 360, 480 and 600 and so on, right? Every 120 seconds he's coming back. The second guy, 200, 400, 600 and so on. So we can see that both will reach the starting point after 600 seconds, right? Exactly after 600 seconds, both of them would have reached the starting point. So the first time they meet at the starting point would be 600 seconds. So the method to solve that is just check the time that one guy would take, 120, take the time that other would take, and then take the least common multiple of these two. So LCM of 200 and 120 would have been 600, right? So that's all we are doing here. Not very difficult. They both start from the same point. The one guy takes 200 seconds to complete the lap. The other takes 120 seconds to complete the lap. And the LCM is 600. So after 600 seconds, they would again be meeting at the starting point. Okay. After 600 seconds, just let's analyze it a bit more. So the guy who is at a speed of 5 meters per second, he would have completed 5 laps. While the guy who is at 3 meters per second, he would have completed only 3 laps, right? Because we are talking after 600 seconds and the first guy takes 200 seconds for 1 lap. So total he would have been covered only 3 laps. Another thing you should notice is that just by looking at the methodology, if they were running in opposite direction, so if rather than in this scenario where they both are running in the same direction, if one guy runs at 5 meters per second in this direction and another guy runs at 3 meters per second in the opposite direction, still the answer for this question remains the same. This guy would still be taking 200 seconds to complete a lap. 120 seconds. And this guy would still be taking 200 seconds to complete a lap. And hence they would meet at the starting point after 600 seconds. So you should imagine the motion and then it should become clear that the answer doesn't change whether they're running in the same direction or in the opposite direction for this question. Okay. So this was the same question and we discussed it already, that if they're running in opposite direction, still for meeting at the starting point, the answer remains the same. You calculate for each of them. He completes 1 lap in 120 seconds, he completes in 200 seconds, and the LCM of 120 and 200 is 600 seconds. So after 600 seconds, they'll meet back at the starting point. Now this is a different question. Here what we are saying is that it's again a circular track, 600 meters. So we are sticking to the same park. The circumference is the same. A runs at 6 meters in one direction, 6 meters per second, and B runs at 4 meters per second in another direction. Now, what we have been asked is where will they meet for the first time, and after what time will they meet for the first time? Okay, so let's look at it this way. Think of this as a straight track, not a circular track, because a circular track sort of messes with our mind. If this is a straight track, the total distance that they need to cover is 600 meters, right? And they both are running towards each other. If it were a straight track, we have opened it up. B is running from here at a speed of 4 meters per second, and A is running from the opposite direction at 6 meters per second. Okay, and the total distance is 600 meters per second. So we discussed such questions last time also. The relative speed with which they are approaching each other is 6 plus 4, 10 meters per second. So the amount of time after which they'll meet is 600 by 10, or after 60 seconds. So after 60 seconds, they'll meet for the first time. And where would they meet? So depending on how much distance A has traveled, so in 60 seconds, A would have traveled 60 into 6 or equal to 360 meters. So they'll end up meeting at 360 meters or somewhere here, right? 360 out of a 600, or you can say 6/10 of that thing. So this is how you can calculate. So if they're running towards each other, their speeds are adding up, and hence they'll meet for the first time after 60 seconds. If they're running opposite to each other, if they're running up in the same direction, in which case their relative velocity, so one way is you can write it directly, 600 by 6 minus 4, or they'll meet after 300 seconds. How did we derive it? So think of it like this. A is running at 6 meters per second and B is running at 4 meters per second in the same direction. So, and A has to get ahead from B by 600 meters to meet B again, right? When will A meet B again? A will keep running faster than B, and at some point it will cross B. So when it crosses B, it means A has run 600 meters more than B. So if you like, again, imagine it as a linear motion, what is happening is A is running at 6 meter per second and B is running at 4 meter per second. And they need to create a gap of 600 meters. So as discussed last time, the relative velocity with which the distance is increasing is 6 minus 4 or 2 meter per second. And to get ahead by 600 meters, the time it will take is distance by speed, or 600 by 2 equal to 300 second. So this is how we get the distance. So if you are running towards each other, when will you meet for the first time? Distance divided by sum of the speeds. And if you are running away from each other, when will you meet? Distance divided by difference of the speed. Now you don't need to learn these formulas, etc. Once you have understood the concept, you should be able to apply it naturally. It's just an extension of the relative velocity concept. So you just need to practice it once or twice or thrice, and then it will come naturally to you. You don't need to memorize all this stuff. Now a question can be, how many times will they meet? Let's say it's a 600 meter track. A is running at 4 meter per second in one direction and B is running at 6 meter per second in the opposite direction. Now let's say they run till they complete 1800 meters. So in that period, how many times will they meet? Okay, so you just saw that they meet after 600 by 6 plus 4, right? Or every 60 seconds they meet each other. Now to complete 1800 meters, B will be taking 1800 meters by 6, or total 300 seconds, right? So it will be taking 300 seconds, and every 60 seconds it will be meeting A. So the total number of time that they'll meet each other is 5. Okay, is it clear? If it's not clear, let me know. I'm going a bit, I think, fast over here. It will be clear if you have at least revised a bit of previous session, but let's see what we are talking about here. So this is a track of 600 meters and B will be running, so they have to cover 1800 meters. Okay. And we have to say how many times will they cross each other in covering 1800 meters. So B is running at a speed of 6. So from the previous one, what we have seen is that they meet after 60 seconds. And how have we seen that? We have said that the distance they need to cover to meet each other is 600 meters, and the relative velocity is adding up because they are moving in the same direction. Like they're moving towards each other or opposite from each other, either way, as you see. So 600 by 6 plus 4, or they meet after every 60 seconds. So if they keep running every 60 seconds, they'll keep meeting each other. Now to run 1800 meters, B, which is faster, will take 1800 by 6 or 300 seconds. So the total time they'll be running is 300 seconds, and they meet after 60 seconds. So how many times in total will they meet? They will meet 5 times. Okay. So let's do the other version also. Which is be actually, I shouldn't have deleted the circle. I'll draw it again. Yeah. Let's do the other version when they're meeting and running in the same direction. So let's say A starts from here at 6 meter per second and B starts from here at 4 meter per second. Okay. And they run till, it's a 600 meter circle, and they run till one guy completes 1800 meters. Okay. Now, how much time passes before they meet each other? So 600 meters divided by 6 minus 4, because now the relative velocity is 2 meter per second. So it has to create a lead of 600 meters, and it's creating a lead at 2 meter per second. So it will take 300 seconds for it to cross B again. And for how much time would A be running? So it's 1800 meters and it runs at 6 meter per second. So it will be running also for 300 seconds. So the only time they would meet is at the finishing line. So basically what will happen is A runs for 300 seconds. And how many laps does it cover? 3 laps, right? Because it is covering 1800 meters. So A will be running once, twice, and thrice. And in that same time, B running at 4 meter per second, in 300 seconds, it would have run 1200 meters or 2 laps. So B would have run 2 laps. B would just have run 2 laps of this. And they would have ended up at this point finally. So they both start, A keeps the lead. And as soon as B completes 2 laps, at the same time A also completes its 3rd lap, and they both end up reaching at this point. So they cross only once. So if they're traveling in the same direction, it crosses only once. So what we have covered till now, before I go into this, let's see what we have covered. We have covered when will they meet at the starting point. Starting point, when will they meet for the first time, where we did u plus v and u minus v for the first time, and how many times will they meet in a certain duration or in a certain so we have covered this. Now this question, what it is asking is not exactly how many times also, but how many points can they meet at. So this is a circle, and how many points can they meet at? And there is a formula for that also. If that, we'll look at the formula, but first let's look at the derivation and then we'll look at the formula. So let's see. We discussed when they meet for the first time, and what we discussed here was that if they are running in the same direction, it becomes 600 by 6 minus 4, or after 300 seconds they'll meet for the first time. Okay, this actually is not a great example. Let me just change the question and then we'll do it, because this will make it a better example. Let's keep one guy is running at 5 meter per second, the other guy is running at 2 meter per second. Okay, and let's keep the same track. So when do they meet for the first time? 600 divided by 5 minus 2, 3. So in 200 seconds, they'll meet for the first time. Okay. Let's see what happens after 200 seconds. So in 200 seconds, A would have traveled 1000 meters and B would have traveled 400 meters. So on a 600 meter track, what does 1000 meter mean? It means you do one round and then 400 meters more, right? So somewhere around this point, 4 by 6 of the circle. So this is where A would have come, and it does one lap and this much, and B just does this much, 400 meters. And so A and B meet for the first time at this point, which is around 4/6 of the circle. So 2/3 is in this part and 1/3 is in that part and 2/3 is here. When would they meet the second time? So when 200 seconds more pass, or A has run 1000 meters more. So A has run now 2000 meters and B has run 800 meters. Where have they reached now? So A started from here, 600, so it has run 2000 meters. So 3 complete laps, 1800 plus 200 meters more. So he would have reached here, 1/3 of the circle, two complete laps and 1/3. While B at 800 would have been 1 complete lap and 1/3. So they meet here, which is dividing the circle by 1/3 and 2/3. And then the next time they meet will be 3000 meters and 1200 meters. And at that point, they have all reached back to their starting point. 3000 meters will mean 5 laps for A and 3 laps for B. So they have again come back here, and then it again starts the same way. So what you'll see in this case is that the two, even if they keep running infinitely, they'll meet at only 3 specific points on a circle. They'll either meet here, or they'll meet here, or they meet here. They won't meet at any other point. And it also comes to a simple formula that if you keep the ratio of the speeds in its most simplified form, so 5, 2, the number of points at which they meet is 5 minus 2 equal to 3. So they'll meet at 3 points. And these 3 points will divide the circle equally. So at equidistant 3 points, they'll meet. So using that kind of a relation, you can also try, like if it was 7 meter per second and 2 meter per second, how many points will they meet at? So 7 minus 2 is 5. So they will meet at 5 points. And those 5 points will be equally distributed. Sorry. So if the speeds were 7 and 5, they would have meet at 1/5 the distance, 2/5 the distance, 3/5 the distance, 4/5 and 5/5. So that way you can very easily derive. Just let's see a scenario in case it's not very clear. So the derivation I have talked about, and if you didn't understand, just go through the derivation again slowly when the video is available, and you will get it. It's not very complicated, but the inference makes you much faster. So just look at that. A is traveling at 10 meter per second and B at 4 meter per second. So how many points will they meet at in a circle? So as we discussed, keep it in the most simplified form. So 10:4 or 5:2. So if they're traveling in the same direction at the ratio 5:2, the number of places they'll meet is 5 minus 2 equal to 3. And they will divide the circle equally. So 1, 2 and 3. That's it. 1/3 distance they'll meet at. The same works for opposite side also. Let me see if I have a question. Yeah. So if they are moving in the opposite direction, then you add the most simplified form. So if it is 6 meter per second in one direction and 4 meter per second in the other direction, and you are asked at how many points can they meet, you just keep it to the most simplified form, 3:2, and so they'll meet at 5 different points. And which are the 5 different points? Again, which divide the circle equally into 5 circles. So 1, 2, 3, 4. Each part will be 1/5 of the circumference. So this will be 120 meters and this will be 120 meters and so on. So now you should know the derivations also which we did, and you should know what we have discussed till now. If you have done all this properly and understand relative velocity, you should not face a problem in the exam. Most questions will be done using similar concepts. So you do not need to be very worried about anything on this, but you need to get very comfortable with what we have discussed right now. Let's see a question. 4 runners are running in the same direction on a circular track in the ratio of 1:2:3:4. At how many points would they meet? So again, direct application of what we did right now. So let's see. So A, B, C and D are running in the same direction and their speeds are in the ratio 1:2:3:4. So at how many points will A and B meet? Let's see. A and B, the differential ratio is 2 minus 1 equal to 1. So they'll meet only in 1 point, and that means the starting point, right? So A and B meet at the starting point. B and C, where do they meet? Again 2:3. So they'll also meet at the starting point because it's 3 minus 2 equal to 1. And same is true for C and D. So these three individually A, B, B, C and C, D meet at the starting point. They don't meet anywhere else. Where will A and C meet? So A and C, the ratio is 1:3. So they will meet in 3 minus 1 equal to 2 places, right? So one would be the starting point and the second will be the exact opposite point, right? Because they'd want to divide the circle equally, as we discussed right now, that the meeting point should divide the circle equally. So this will be the first point, this will be the second point. At how many points will A and D meet? That is 4 minus 1 equal to 3. So they will divide the circle in 3 equal parts. So A and D will meet here and here. So this distance will be 1/3, 1/3, 1/3 each. So that's there. And same B, D will meet at 2 parts which means the same existing ones. If you are meeting at two parts, you'll meet here, and that's it. Those are all the combinations. So overall, they'll meet at 4 points. And if you're asked where all A, B, C, and D would meet, that would be the starting point, because that's the only point common to all of them. So they can only meet at the starting point. And overall, if any two is taken, then they can meet at 4 separate points. You can also be asked which are the points where any three can meet, and for that you try and solve yourself. I won't cover it today, but you can solve just based on what you have heard. And itni thinking, though, you should apply yourself. So try and do that. Okay. We'll look at clocks, but in case any of you are having any issues, any problems, feel free to type in your comments. I am looking at them, so if you have doubts, you can ask. So clocks are a special case of circular motion. We just discuss it because if you don't discuss it, you might find them a bit more complicated. Just discussing them for 5 minutes helps you get a lot comfortable with them. So we'll just spend those 5-10 minutes, which make it very useful. There are two hands, the hour hand and the minute hand. You can imagine them the same way, that they are both running around a circular track. The minute hand is faster, the hour hand is slower. The speed of hour hand, here what it helps is sometimes keeping it in degrees. So the hour hand covers 360 degrees in 24 hours, right? So on a per minute basis, the hour hand covers, in 12 hours. So our hand covers 360 by 12 degrees in 60 minutes, right? And so it covers half degree per minute. So each minute the hour hand moves by half degrees per minute, and the speed of the minute hand covers 360 degrees in 60 minutes, or the minute hand covers 6 degrees per minute. Now that is useful, and how we will see just now. Let's say there are 3 o'clock is the current time, and so you can see the difference between both of them is 90 degree, both the hands. You are asked at what time would hour and minute hand coincide. When would hour and minute hand coincide? Okay. So you have been asked when would hour and minute hand coincide, and how do we solve it? So though 90 degrees is the distance that needs to be covered, and the relative speed of the minute hand versus hour hand is 6 degree minus half degree, or 5.5 degree per minute. So per minute, the hand is covering 5.5 degrees. So how much time would it take for it to cover 90 degrees? 90 by 5.5, right? Or 450 by 11 minutes. 180 by 11 minutes. Made a mistake. 180 by 11 minutes. Okay, and then you can simplify it. I think it comes to what? 16.4 by 11 or 16.36 minutes, and then you can see whichever option is closest and all that. But this is how it helps you solve questions. If you haven't done this before, then you would never be able, you'll find it tough to think through all that. But looking at it in degrees per minute helps. Looking at it in terms of relative velocity helps. So if we had, the answer would be 3 hours 16 minutes and around 36-37 seconds is when the hands coincide. Let's look at this, a very common question. Some of you might have come across it. How many times will the arms of a clock cross in a day? So how many times the arms of a clock cross in a day? So we just saw the minute hand has a speed of 6 degree per minute, and the hour hand has a speed of half degree per minute, right? And how long is the track? Oh, sorry. How long is the track? The track is 360 degrees. So, so this is again a similar question to what we were doing earlier. If you can recognize it, that there is a set distance, and how many times will the faster guy cross the uh, smaller guy? And you can actually it's just that in that how many times the arms of the time you have is uh, so the number of hours you have in the day is 24 into 60 minutes. So this is the time in total which you have. So yes, so how many degrees would the minute hand travel in the day? 6 degrees per minute into 24 into 60 divided by the total number of degrees that are there in one round. So 360 degree. So this is the time that turns that it will take, and the number of turns that our hand will take would be half into 24 into 60 by 360, and then you can subtract. But the easier one would be you just take the relative velocity. So uh, at sorry at 11 by 2 degrees per minute, it's traveling at the total number of minutes are 24 into 60. So this is the number of extra degrees it is traveling, and then you divide by 360 to get the answer that okay. These kind of questions are also common. What is the angle between two hands of a clock at 2:20? So this is very similar to what we did previously. You had at 2 o'clock, the angle between them is the total is 360 and 60 degrees. Okay. So the angle between them is 60 degrees. And then you are asked what is the angle between the two hands at 2:20. So in 20 minutes, the relative velocity is 5.5 degree, right? So the minute hand is catching up at a speed of 5.5 degrees. So in 20 minutes, how many degrees would it have traveled? 20 into 5, 1 by 2, or 11 by 2 into 20, or 110 degrees it would have traveled, right? So it was 60 degree behind, and it travels 110 degrees in the 20 minutes. So 20 minutes, 110 degrees extra in the 20 minutes, because we have taken 5.5 at the relative speed we have multiplied it by. So at the end, at 2:20, it would be 50 degrees ahead, or the difference between the two hands will be at 50 degrees. I'm aware we have been pretty fast through all this because I also wanted to do the questions today, but I will take a couple of minute pause here. I can see I have lost a lot of people also because I think probably I was much faster than should be. But we'll stop here for a couple of minutes and then we'll continue. If you have some doubts, some questions, feel free to comment and then we'll get started again. Let's look at this question. Yeah. So Anu and Prem are diametrically opposite. So Anu is there and Prem is here. And they run in opposite direction. So they both run in opposite direction. And they meet after 12 minutes. Okay. And then it says if the distance between them exactly t minutes after they start is equal to quarter of the length, which of the following is not a value of t? So if you understand the circular motion properly, it's easy. Let's see how we'll do this. So in 12 minutes, they meet for the first time. And which means that using their combined velocity, they have covered half the circle in 12 minutes. So how much time will they take to cover the entire circle? 24 minutes. Okay. So they meet for the first time after 12 minutes, and then they have to cover the entire circle to meet again. So the timings at which they'll be meeting is 12 plus 24n. N can be any integer. At these points, they'll meet each other. But we are not concerned about meeting. We are concerned about when will they be quarter of a length, when they'll be a quarter of the length of the track away from each other, right? And that will be 12 plus 24 is at a point at which they meet. So to cover a quarter of the length, they probably take 6 minutes more, right? So plus minus 6, right? So so that will be 24n plus 18 or 24n minus 18. If a number can be written in these formats, then that number is a possible value for t. If a number cannot be written in these format, then it's not a possible value for t. And you'll notice that 144 is the only one which cannot be written like that. So that's how you get the answer. But the concept here is more important because it's a very conceptual question. If you understand this, you do understand everything about circular motion more or less. So I can go through it once more. Let me explain to you. Anu and Prem start from opposite ends. They meet after 12 minutes, which means that they cover the entire circle in 24 minutes. They cover half the circle in 12 minutes as has been given, and they cover quarter of the circle in 6 minutes. Okay. So we are asked what is the value of t when they can be quarter of the length away from each other, right? So they will meet each other after 12 plus 24n times because they meet for the first time after 12 minutes, and then they have to cover the entire track which takes 24 minutes. So they will meet after 12 plus 24, 12 plus 48, 12 plus 72 and so on, and they'll be at a distance of at a quarter distance from each other 6 minutes before and 6 minutes after. So they'll be approaching each other, so they'll be at a quarter distance, and then they'll cross each other, and then again there'll be a stage where they'll be at a quarter distance. So they'll be at a quarter distance at plus minus 6, and that gives us the number 24 and plus 18. And sorry, I think I made a mistake here. 24 and plus 6. So if a number can be written like this, then it is a possible value for t. If it can't be written like this, then it's not a possible value of t. Let's look at this question. Two cars start simultaneously from cities A and B towards B and A respectively. On the same route. Once the two cars reach their destination, they turn around and move towards the other city. Okay, so what here we are saying is that there are two cities and they are 120 kilometers apart. Okay. And there are two cars which are continuously shuttling between these two cities. So A comes, the car goes there and then turns back and comes here. And then there is another car which starts from B and it goes and it keeps coming back. And that's what they do the entire time. Now they do this for 20 hours. So for 20 hours, they keep shuttling between the two cities. And we have been asked to identify number of times the two cars meet. Now this is not circular motion, but it can be interpreted as circular motion. This is very similar to just a circular motion question where one person is moving at 60 kilometers, the other person is moving at 40 kilometers, and they both just start from opposite point and they keep running for 20 hours. And here the circle's circumference will be 240 kilometers. Okay. And you can solve it using this fairly quickly, like in a minute you can solve this. Otherwise it would take a lot of time to get to the answer. But if you have seen this, then it's not very difficult, because they have been running for 20 hours. We know after how much time do they meet. They will meet, they have to travel 240 kilometers, the relative velocity is 100, so they will take 2.4 hours to cover the entire thing. And the first time they'll meet after 1.2 kilometers, because the first time they only have to cover half the distance. So they do 1.2 and plus 2.4 t, where t can be any integer. They keep meeting and they do it for 20 hours, right? So we have to find which the value of t for which 1.2 plus 2.4 t is less than 20. And that you can assume, if you substitute, you can check. I think t equal to 7 is the one where it comes. So for t equal to 7, yeah, t equal to 7, the number will be less than 20 hours, and t equal to 8, it will be more than 20 hours. So they meet 8 times, first time after 1.2, and then 7 times again. So this is an application of circular motion, although the question doesn't look like circular motion. So you should be able to solve and practice. This is a good question, I assume. Let's look at this one. So there is a city A, and C1 left at 6 a.m. and C2 left from the same city at 9:30 a.m. So after 3.5 hours. And the speed of B city, sorry, I confused the names. So city is C1, car A left at 6 a.m., car B left at 9:30 a.m. And car B speed is 12 kilometers above A speed. So at 4:30, so they have been traveling, and at 4:30, the distance between A and B is 91 kilometers. Okay. So A is still 91 kilometers ahead. If they have been traveling, find the speed of car A. So again, it should appear to you it's a direct usage of relative speed. B has 12 kilometers on A. So by 4:30, that is in 7 hours, B would have caught up with A by 12 into 7, or 84 kilometers. And it is still 91 kilometers behind. So the total distance that A was ahead when B started was 91 plus 84, or 175. So A was ahead by 175 kilometers, and that means that A had traveled 175 kilometers in 3.5 hours. So speed of A would be 175 by 3.5, which is the difference between their timings, and that gets you 50 kilometers per hour. Again, once you understand relative velocity, it should be straightforward. A started 3.5 hours earlier. B was gaining 12 kilometers in every hour for the 7 hours B drove. So it gained 84 kilometers, and still A was 90 kilometers ahead. So A was probably 91 plus 84, 175 kilometers ahead at the starting point. And so A had traveled 175 kilometers in 3.5 hours, which means A had traveled 50 kilometers per hour. This one is a good question. I'll zoom in just so that you can see. So here the question is, there is a tunnel and a man is caught in between. a man is caught in between and he's at 2/5 the distance. So he's caught at 2/5 the distance. When he sees a train approaching, so he sees a train approaching, and now he has two options. He can either run in this direction or he can run in this direction and try and escape. What the question tells us is that whichever direction he runs in, he will get hit at the end of the tunnel. So if he runs in this direction, he will get hit over here. If he runs in this direction, he will get hit over here. And then we are told to find the speed of the train. The man's speed is 10 kilometers per hour. Okay. Let's analyze the two scenarios. If he runs in this direction, he is at 2/5 of the tunnel. So he runs 2/5 of the distance of the tunnel, and the train has reached the opening, right? Because that's why he has that accident. The train has reached here. So by 2/5x, the train has reached here. If he runs in the opposite direction though, let me make a good tunnel. Not very good, but will do the job. By the time he has to run from here to here, 2/5x, he has reached here. We know by that time the train has also reached this end of the tunnel. The train is here. And then by the time he runs the remaining distance, which is x minus 2/5 minus 2/5x, which is x by 5, the train covers the entire distance of the tunnel, or entire x. So in the time in which our man covers x by 5, the train covers x. So what is the ratio of the man's speed to the train speed? X by 5, or train speed to man speed? 5:1. So because the train is covering 5 times the distance the man is in the same time interval, which means the train speed would be 5 times the man's speed, and the man's speed is given at 10. So the train speed will be 50 kilometers per hour. Again, not very easy if you do it the wrong way, but if you think of it in the correct manner, it's fairly easy and is a good application of relative speed and how to solve. So I would again encourage you revise, because you can face a similar question in a different scenario, and then it would be good if you have yes. Okay. I put this one in also because you might face such questions. I think it's slightly bigger. So there are two pipes which are covering a tank. So there is a tank, there are two pipes. Okay. One pipe's area is 15 centimeters square, another pipe's area is 25 centimeters per square. And they're able to fill the tank in 40 minutes. Water comes out from one tank at 2 meters per second and another tank at 6 meters per second. So we are asked to determine the volume of the beaker, or volume of the tank. Now here you need to know this. How much water comes out of a pipe is cross-sectional area. Okay. Cross-sectional area into the speed of water coming out. This will be the volume of the water coming out per unit time. And then you multiply it with time to get the total volume of water coming out. Okay. So what I mean is this. If this is a pipe, and we can see how the formula gets derived at also. I'll just again try and draw a pipe first. This is a pipe and water comes out of it at 5 meters per second, and its area is say 20 centimeters square. Then how much water comes out from it in 1 second? That is equivalent to the water that will be stored in 5 meter length of the pipe, right? Because all that water is coming out. So in 5 meter length, how much water will be there? That will be the area of cross section, 20 centimeters square. You can adjust for units, but into 5 meter or whatever is the speed. So that much water comes out in a second. And then if it comes out for 10 seconds, you have to multiply it with the number of seconds to get the total water that has come out. So using the same formula, 15 is the unit also we need to be wary of. So 15 centimeter square is the area, cross section area, which means 15 by 10 to the power 4 meter square is the cross section area. 1 centimeter square is equal to, if you don't remember, 1 by 10 to the power 4 meter square. So be careful here. So that's the meter square area of that. Water is coming out at 2 meter per second, and it is coming out of for 40 minutes or 240 into 60 seconds. So this is the water that has come out from the first pipe, and then we need to add the other pipe. So 25 by 10 to the power 4 into 2 into 40, into 6, which is the speed. And this one will be the water that has come out in meter cubes. And now you just need to simplify. You can take a few things common. Just take the common element out and then add. So 15 into 2 is 30, 25 into 6 is 150, 150 plus 30, 180. So you need to do, this will be equal to 180 into 40 into 60 by 10 to the power 4. And then there are 3 here, so you get cancel all 3. 18 into 470, 18 into 24, right? 6 into 4, 24 into 18. So whatever it is, 480 minus 48, I think 43.2 meter cube. So that's the volume of water that has come out. Is the video resolution not that great? I'll figure it out by next time. Let me know. I'm sure I can make it better. Sorry, I marked the wrong answer because I got distracted by the video resolution comment. I'm sure I can make it better. I need to figure out how. It's a technical question that I'm a bit struggling with. But if it's not great, I will try and do it better next time. This time, if I start making changes right now, I might mix something up. So hold on to what we have. I'll try and zoom in and make the font sizes bigger and write bigger to ensure that you are able to see. This question, so a traveler, he takes 15 hours traveling in one direction. So I'm writing the question in case you are not able to read the question, as it seems to be the case. I can zoom in also, but then you will miss some of the details. Yeah. So in this question, a traveler is traveling from A to B, and he going to A to B, he takes 15 hours, and coming from B to A, he takes 11 hours. So just by looking at this, you know that the speed is not the same in both directions, right? Otherwise, you would have taken the same time. Now the traveler's speed going uphill, when he goes uphill, it's 40. When he goes downhill, his speed is 60. And on level ground, he travels at 48. Okay, this has been given to us. And then we have to find the distance that he travels from A to B. So this is the only thing that has been given, and we've been asked to travel the distance from A to B. So it's clear that it's not level. There has to be some uphill dimension in the travel. That's why his speeds are different, because one direction he goes uphill, other direction he comes downhill, so his speed increases. B may probably he has more downhill and A has more uphill because speed is lesser. Now what we need to do this faster is, so his uphill to downhill speed ratio is 40 is to 60 or 2 is to 3, right? So we remember speed is equal to distance by time. We did it in previous class ad nauseum, that if distance is same, speed is proportional to time, right? So if he's taking if his speed is 2 is to 3, for that particular distance, his time would be in the ratio 3 is to 2. Okay. His time for the uphill downhill part would be in the ratio 3 is to 2. When he's going uphill, he takes 3x time. When he's coming downhill, he gets 2x time. And for the level part, he will take the same time going or coming back, which means that the 4-hour difference that we see in the time in going and coming back is just because of this difference, right? So 3x minus 2x is actually 4. And from that, you can get x is equal to 4, which means that for 12 hours, he goes uphill when it takes him 15 hours, or he goes 8 hours downhill when it takes him 11 hours. Okay. And using this, you can solve the question. The question is, what is the distance that he travels? So, if you're taking 15 hours, 12 hours is uphill and 3 hours is flat. So uphill, the speed is 40. So you can just do 12 into 40 plus 3 into 48. And whatever this comes to, 480 plus 144, 624 kilometers. But the way we have solved is much more interesting, and you should try and understand. What we had was that he goes uphill at 40 and he comes downhill at 60, and on flat he travels at 48. Now his uphill to downhill ratio is 40 is to 60 or 2 is to 3, right? So if its speed ratio is 2 is to 3, for the same distance, the time he would take is in the ratio of 3 is to 2, opposite, right? Because distance constant, speed and time are opposite. So if he takes 3x distance or 3x time in going uphill and 2x time in going downhill, the difference in time that we see, 15 minus 11, 4 hours, can only be because of that. Because on the flat ground, he will take the same amount of time going and coming back. So from there, we get 3x minus 2x equal to 4, or x equal to 4, using which we know that he takes 8 hours to go downhill or 12 hours to go uphill. And then out of the 15 hours, 12 hours are uphill and 3 hours are plain ground. So you can count the distance, or you can count the distance using the downhill number. 8 hours is downhill and 3 hours is plain ground. So you can use that to solve the question. Right? This is again a circular motion question. You try it yourself. It's not very difficult. I think you can solve it, most of it. This one is a relative velocity, good application. So it's based on races, etc., which we did last time. So you should be able to use those concepts if you remember. So there is a 300 meter race, and Soumya beats Divya by 10 seconds or 50 meters. So in the 300 meter race, when Soumya completes 300 meters, Divya has completed only 250 meters, from which we know that in the same time their distances are in the ratio 3 is to 2, or 3 is to 300 to 250, or 6 is to 5. So their speeds are in the ratio of their distance, which is 6 is to 5. Also, it's given that she beats her by 10 seconds, which means that Divya covers the next 50 meters in 10 seconds. So we know Divya's speed. So what is Divya's speed? 50 meter by 10 or 5 meter per second. And so Soumya's speed is 6 meters per second, because the ratio is 6 to 5. So there is another race where she gives Divya a head start. So now Divya is starting ahead. Divya gets a head start of 150 meters. And Soumya so Divya starts from here. Now Soumya has increased her speed by 1.5 times. So Soumya's speed becomes 9 meter per second. And increased by 1.5 times. So she may increase it actually to 2.5 times. So Soumya's speed becomes 15 meter per second, and which is actually better than the gold medal. So the question doesn't make sense practically, but yeah. And Divya's speed is now double her speed in the previous race. So Divya is at 5 to 10 meter per second. So Divya is running at 10 meters per second. Soumya is running at 15 meters per second. Divya started with a head start of 150 meters, and then they finished the race at the same time. So we are asked how much time, how long was the race. So Soumya's relative speed is 5 meters per second compared to Divya, and she has to cover 150 meters. So 150 meters she would cover in 30 seconds, and so the race should last 30 seconds. And for the race to last 30 seconds, how long should the race be? At 15 meters per second for running for 30 seconds, she will be running a 450 meter race. So 450 is the answer. This question I think I took from people who had posted on the group to answer. So I'll do this one. Two Indian tourists in US cycle towards each other, one from point A, another from point B. First tourist left point A 6 hours later than second left point B. So there is A and there is B. So T2 leaves B and then T1 leaves B 6 hours later. Okay. And when they meet, T1 has traveled 12 kilometers less. Okay. After that meet, they keep cycling, and the first tourist arrives at B 8 hours later. So after meeting at some point, T1 arrives here at x plus 8 and T2 arrives here at x plus 9. Find the speed of faster tourist. So now we have to find the speed of the faster tourist. So let's think about it. One thing which we know is T1 starts 6 hours later and reaches 1 hour earlier than T2, right? So T1 starts 6 hours later and reaches 1 hour earlier. So T1 takes 7 hours less than T2. I shouldn't have used T actually. T would have liked to keep for time. But T1 took 7 hours less than T2 for the same distance, right? Speed equal to distance in time. Distance is constant here. So if tourist 1's speed is S and his time is T1, then for tourist 2, S2 into its time becomes T1 plus 7 because he took 7 hours extra, right? So that's one you get. And we have to calculate the speed, right? The first tourist left and turned out to their meeting that he had traveled 12 kilometers less than the second tourist. Now, where do we get our other equations from? So let's see what information we haven't used. First tourist left point A 6 hours later. Fine. He has traveled 12 kilometers less than the second tourist. So the second tourist has traveled 12 kilometers more, and just a second. So and this is equal to the total distance. So just let me think about it. So the second equation, we need to use this information where he had traveled 12 kilometers less than the. It's just slipping me right now, but look, I'll need to think about it a minute or two. So I'll post the answer after a couple of minutes. It's just slipping me right now how we exactly make that equation. I think So it will be actually like that. So S2 has traveled for 6 hours. So it has traveled this distance. And then they have, and after that, the distance that S1 has been covering extra, uh, it's fine. I'll think about it and then I'll post the answer because it's just slipping me right now. There is a simpler solution. I solved it very just before the class, but right now it's slipping me. This one was the other question which was posted. This is straightforward mostly. Just one part which is slightly confusing. So two trains A and B start simultaneously from station X and Y, both 180 kilometers apart at 11 a.m. Uh, Speed of train A and B is 75, 70 and 50 respectively. Train A does not stop anywhere during the journey. This should be journey. But train B stops for 15 minutes at station Z, which is 60 kilometers away. So, what is the distance nearest kilometer from station X to the point where? So the only thing is, so they're traveling at 70 and 150. The total distance is 180. So if it were not for stopping, we would have known how to do it, right? 180 by 70 plus 150 or 120, and that would have mean in 1.5 hours they meet, and we would have solved it. But what is throwing us off here is that the train B stops for 15 minutes after traveling for 60 kilometers. So how does that differ? So ideally, it does not make any difference. If it stops after crossing, then your crossing point remains the same. If it stops before crossing, then you just assume that it happened initially. So the first train which started from here at 70, it had traveled for 15 minutes and then you do the entire thing. So let's say here it stops after crossing 60 kilometers. So 60 kilometers train B will travel in 60 by 50 or 1.2 hours. Okay, and they would have crossed after 1.5 hours. So it stops uh, after it stops before they would have crossed, right? In which case you just assume that they just assume that the stoppage was in the beginning. So if you assume that it stopped initially, if you just assume it stopped initially, then for 15 minutes only train A was traveling. So it stops for 15 minutes, right? Yeah. So 15 minutes, just A was traveling at 70. So it had already traveled 70 by 4 distance. So the distance that remained was 180 minus 70 by 4. And this you divide by their approaching speed, 120. And in this time, you just add the 15 minutes at the beginning. So the 15 minutes at the beginning, you just add this, and this becomes the time at which they cross. And then if you want to calculate the distance, you can just multiply it by the first train. So 70, so you can multiply, and this will give you the distance. So basically what you are doing is you are assuming that it stops initially, rather than taking it that it would have traveled some distance and then stopped. You just assume that it started 15 minutes late, and then you can solve for that. Uh, this is a very similar question to what we had done in the previous class. We had similar ones done previously. So uh, try and revise that. If it's still confusing, we can again cover it. But you have to assume distance constant, and then you can make your equations in speed into time. Somewhat similar to actually this one also. Where I not know where I got stuck. So I'll look at this one and post a response fairly soon. But otherwise, this was the class. I think we have covered a lot of questions. Less people have attended today, but those who haven't, it would be better if they also revise properly, and then you should be fairly comfortable with the speed distance related question. If you revise all these questions, the ones that were covered in the first session and this session, I cannot see a lot of other combinations possible, because there is only one equation, speed equal to distance by time, and using that, how many questions can you form? So if you are comfortable with this, then in the exam you should not be able to make mistakes or miss any of the question. You should be able to solve most of these questions. Okay. We'll stop here. If you have any comments or suggestions, feel free to message. And I'll try and improve the resolution from next time. I realize that it is a problem. Okay. Thank you.